Yeah, they had like a full-on conversation. Okay. Alright, so we do have quite a bit of vocab today. Good morning. First one is a set, which is just a collection of objects whose content can be clearly determined. Collection of objects whose content can be clearly determined. And then elements are the objects that are in a set. They could be numbers, symbols, words, pictures. So we could have like this set of natural numbers. 1, 2, 3, 4, 5, 6, 7, so on and so forth. We could have this set of seasons. Fall, spring, summer, and winter. So you can have numbers, you can have words, all kinds of different things. So today we're looking at basic facts about sets and then the 3 different forms that you can write them in. So the first fact is that capital letters are used to name sets. Sets are usually enclosed within braces, okay, which some of you are going to be really good at drawing, and some of you aren't. And if you hate these, I'm really sorry for what we're about to do in this whole chapter. Because almost every problem you have to draw them.
I like them, but I'm more good at them.
Just give them your best shot.
You can draw the right one, but not the left one.
And we will use commas to separate the elements. So if we're listing things, like 1, 2, 3, 4, so we'll know what's different. And the order of the elements is not important. And I don't know why some letters keep getting cut off in my slides. So you don't have to put them in order from least to greatest or greatest to least. I usually do, but you don't have to.
Next time I listen to the video, I'm going to listen to the crunching of food.
I can hear it. That's my cheers when you're crunching.
Alright, so there are 3 ways that you can represent sets. The first one is word method. This is using words.
Really?
Using words to describe a set.
Oh wait, hi Frankie.
Hi, Frankie. Hi, Brandon.
We know she won't watch this. I hope she does.
And then other people that should be watching this are Will, Sloan, Bailey, Hunter, and Kyle. Hi to you all. We missed you today on the 19th.
Senior skip day.
Alright, so an example of word method set W is a set containing the days of the week.
Wait, Will was here today?
Yeah, really was this one.
No.
She also had another sister. Oh, and hi Sydney. Sydney Shrub. I think she's singing. Field trip. So yeah, I talked to 3 people last period. It was great. Alright, so word method is the most obnoxious if you have to write it, because it's like the longest type of problem. The next one's called roster method. So think about my roster that I have with the class. Right? I have a list of all of your names. So for roster method, you're going to list all the elements separated by commas. And you're going to use your braces to do that.
Wait, can you also do brackets? Or is that not?
It's not proper, but if that's all you can draw.
No, I mean like I can do the one.
Like I've had students just do parentheses because they just can't. Or just like, I've seen this.
I have to like split them up like to the top.
Pardon the interruption. This is McCarthy. Please dial extension 6503. Mr. McCarthy, 6503.
When I get students to the board, like those people that are good at it, they're real confident of their drawing.
I have to flip the paper around to do the other way.
I did it.
Alright, so here's roster method using, the same example from the last one. Okay, so W equals, we have a brace. Normally you write out the whole word, but we don't have time nor patience. So we abbreviate Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then we should have a brace closing. Oh my god. Are those like fire hot Cheetos? No,
Always.
I can just tell by the color.
That's all she used. You should try to have a move on.
Didn't you just have a
I don't want to
practice
do
before that?
so bad.
Yeah.
Aren't you gonna run there and move on?
Yeah.
Because
I'll show up for work method.
yes. I'm on film. On our break. I'm on film. Yeah, I'm on film.
You say a mukbang?
Yeah.
Oh, Frankie did that before.
All right, last one is called set builder notation. And it's an algebraic method to represent sets. You may have seen this in pre-calc if you took pre-calc. But sometimes you would do this with like domain and range of things. Ours will be a little bit easier. We're just listing things. But some students struggle with like how to remember to do roster method. Usually you don't have to remember what it looks, or set builder notation. You don't have to memorize all that stuff because you could go look at another problem on your quiz and then just kind of copy, model that off of that. But what everything stands for here is set W equals is our is. Oops. And we have our brace, which will be the set of all elements. So this is all elements X. And then the bar stands for such that. And then you put whatever that set has special about it at the end. So set W is the set of all elements X such that X is a day of the week. So all three of these examples are the same set, just represented in three different ways. Sometimes you'll see ones that are more algebraic. So you might see like P is equal to the set of all elements X such that X is greater than 7. So listing numbers greater than 7. Okay. There's some algebraic ones and some word problems. So you just have to pay attention to the directions and use the method that they want. So this one says to use roster method to represent each set. Right now it's in word method, words. We're going to switch to roster, which is listing. So C is the set of US coins with a value less than $1. We'll start out C equals. Draw your best phrase. What kind of coins are less than $1? And $50 technically, even though no one uses them. But yes.
People use them.
Sometimes.
Jenna got really offended. I did. Because it was a big deal. Because I was like, I don't know what to do with this.
So again, just separate them by commas and enclose them in a set of phrases. Next one, M is the set of months beginning with the letter J. So M equals the set containing what months begin with J? January. June. Okay. So we've gone from word to roster. The next set of examples goes from roster back to word method. All right, so the next one, we want to use word method to describe the sets. We have the colors red, yellow, and blue. What type of colors are those? Primary colors. So we'll say that set P is the set containing primary colors. Usually I don't on the quiz pick any ones that you would need like prior knowledge of. You might not remember primary colors, especially if you weren't in any of Miss Elevator's child development classes.
I was in the
Once you hear it, you're like, yeah, but I wouldn't have thought so.
I saw that.
All right, next one, set P is the set containing, now we can't just say letters in the alphabet because that would have to have all of the letters, but it stops at F. So we'll just count 1, 2, 3, 4, 5, 6. We'll just say it's the first 6 letters of the alphabet. So Again, this is the longest one. Set P is the set containing first 6 letters.
I think this is the first time I tried to spell the word alphabet.
Alphabet.
I hate how I spelled it wrong.
Did you use an F?
I put an E in there. Like not at the end, like in the middle.
Alphabet.
I did that.
Lucky for you on the homework, I don't think they have you doing any word method, because it's the longest. It's annoying. But they'll give you word method and ask you to use a different method. Okay, example 3, they give us it in set builder. We're asked to go back to roster. So roster is listing. So we're going to have A equals. So we have all elements X such that X is a month that begins with the letter M. So March and May. Just a list. Make sure you don't forget one. Like go through the whole calendar on your quiz. Some people forget one. All right, O. So the set O contains all elements X such that X is a positive odd number less than 10. So positive 1, odd 3, 5, 7, 9, less than 10, that would be it. So 1, 3, 5, 7, 9. Those are these. Next vocabulary word is the empty set. So there are sometimes no elements that exist in a set. For example, X is a month of the year that starts with the letter T. None of the months start with the letter T. So we would say it's an empty set. So the empty set, which is sometimes also called the null set, N-U-L-L, set, is a set that contains no elements. And you can either represent it with a set of braces with nothing inside, or we can put a 0 with a slash through it, or an O with a slash through it. Some of you will remember that from pre-calc, when there was no solution. You've heard that sometimes. So my example here, R is the set of all values X, such that X is a triangle with exactly 5 sides. Triangles have 3 sides, therefore it's an empty set. And then the last one I just reviewed, we did these earlier in the year. Does anyone remember what natural numbers are? There's like natural, whole, integer, and rational we talked about.
Is it natural, just like the regular ones with 0?
Not including 0. So natural numbers are called the counting numbers. So they were like, if I'm counting, I wouldn't start out with 0, 1, 2. I'd start 1, 2, 3, 4, 5. So the natural numbers are numbers that occur in nature and counting. They're called the counting numbers, and they're represented by a capital N. So anytime you see a capital N, you'll assume that that's talking about the list of positive whole numbers, not including 0. Is that color okay for you guys to see? No?
I'm half blind anyway.
He doesn't talk. Yeah.
It's like hard for me to see it up here. But I think I have to like fill each.
Looks like WVO.
Yeah, not like that either.
Head.
No, we don't like that.
There you go, Ben. Thanks, Ben. There's always a really bad glare over here. All right, so our whole next set is just, is it the empty set or is it not? So you can put the empty set symbol or put not the empty set. So we have X such that X is a month that begins with the letter Z. Are there any months that begin with the letter Z? No, so this would be the empty set. Whoa. Forgot to switch out of there. So you can either just put the symbol or you can write out empty set. Or you could put the symbol for the empty set, which is, or a set with nothing in it. Any of those two things will go. How about the next one? Set containing 0. Is it the empty set? No, there's one element in there. It happens to be 0, but this has one element. So it's not empty. Some of these get tricky. C. It's not a set. It doesn't have braces. So this is not a set. Therefore, it cannot be the empty set. Okay, then we have some algebraic ones. Be careful with the word or and and. So it says x such that x is the number less than 4 or greater than 10. So one or the other. So numbers that are less than 4 would be a bunch of negatives, but like 1, 2, 3. And then or numbers that are bigger than 10, so that would be like 11, 12, 13. And technically, you should also include decimals in there, but we're not going to list them all. But clearly, there's lots of elements in that set, so this would not be empty. Again, the word or tells you one or the other. Hello? Nope. Now, the next one has the word and, which means both things have to be satisfied at the same time. So can a number be less than 7 and greater than 25 at the same time? No. So since you can't have both of those things at the same time, this would be empty. There would be no elements, no numbers that can satisfy that. And then saving the last one to be the most tricky of them all. Do we think it's empty or not empty? Raise your hand if you think that's the empty set. Raise your hand if you think it's not the empty set. This is not the empty set. It has braces, which is a set. It has an element in it. The element happens to be the empty set symbol, but this is actually one element. So the only way that you can look at the empty set and know that it's empty is if it's a brace, nothing in it, or if it's the symbol for the empty set. You can't have one inside the other, because then it has something in it. Because technically...
Pardon the interruption. Brandon Perard, please report to room 262 immediately. Brandon Perard, please report to room 262 immediately.
Yes.
I love that that's recorded.
So you can have symbols in this set. We haven't done any with symbols, but this is really just a symbol too. So you can put symbols inside of your sets, and that would be 3 elements. So just make sure you don't get tricked with that one. All right, last vocabulary, I guess, or symbols, are the E's. They look like a capital curved E. Perhaps. Here we go. Okay, so these are set membership. This means an element of. So the next one with the slash through means not an element. Indicates an object is an element of the set. Meaning it's in the set. Something that is in that. So for example, oops, B is an element of the set A, B, C, D. B is an element in that set. Again, when you're reading it, you'll just think is an element of. Stick a slash through it, it means that it's not an element of the set. Back to here. What's this one? Just like fonts falling out. so the example for this one is that B is not an element of the set containing X, Y, Z. B is not in that set, so that's not an element. So they just ask us to write true or false for each of these statements. So is R an element of the set containing all the letters in the alphabet? This is the dot, dot, dot. Yes. True or yes? Is 7 not an element of the set containing 1, 2, 3, 4, 5? Yes, 7 is not an element. This will be true. Now, if it had said, is 7 an element of, we would say false. Since it's not an element, that's a true statement. Then the last one is the trickiest. The answer is false because of these. Okay? If it said just, is A an element of? Yes. But because it has braces of A, so we'll put false. For it to be true, it would literally need to look like this. Like you'd have to have a set of braces inside of it. Those are really bad. But for this to be in there, you'd have to have the braces around it too. So the elements that are listed up front never get braces around them. So it's like a trick question almost. All right, our closure are the same type of questions, but I want to go over a couple because you haven't seen any of these. So when you see that X is an element of N, that means X is an element of the natural numbers. So remember, natural numbers are 1, 2, 3, and so on. So you're thinking they're natural numbers and they're less than or equal to 4. And we're doing this in roster, list method. They didn't give us a name for it, so let's just say S, set S equals. I'm just making that up since they didn't give us one. What numbers are natural numbers and are less than or equal to 4? 1, 2, 3, 4. Next one, we have X is an element of our natural numbers, which usually that's the set they're going to use. They don't use integers a lot. They use natural just to restrict only positive numbers. And X is greater than 5. So what numbers are natural and greater than 5? Would we include 5? No, because there's no equal bar. So we'll start with 6, then 7, then 8, and then you can just stick a dot, dot, dot because we're not going to sit there and list every single number to infinity. We'll learn later next week. This is called a finite set, has a finite number of elements. This is called an infinite set because it goes on forever. See if you can try the last one. It says that 7 is less than X is less than or equal to 11. You can also think of it as that X is in between those two numbers, in the middle. X is an element of the natural numbers. So that's 1, 2, 3, 4, dot, dot, dot. And it has to be between 7 and 11. So would we include 7? Would we include 8? 9? 10? How about 11?
Yes.
Yes. Okay. So this is like an and compound inequality from out of it.